Hello, everybody. This is Mr. Yosef. Today we are going to talk about compound interest. So, a couple things I just want to say first is sometimes it's math. It's just easy to plug stuff into a formula and not understand what it means. So, what I'm going to try to do today is do my best to explain this idea of compound interest. So, what I want us to think about is think about that you have $100, okay? And that your parents made you a promise. Your parents say that if you take this $100 and you save it and you don't spend it every year, we will give you 10% of the amount that you have. So we're going to call that a 10% interest in your favor. So one big thing about interest is it negative, is it positive? It depends on the context. If you're putting in a bank account or you're investing it, then of course it's a positive thing. But if you are paying fees or borrowing money, then it becomes a negative thing. So in a year, if you don't spend $100, your parents promise you 10%. So all you do is 100 times 10%, which is $10. This $10 represents the interest you earned. Thus, at the end of the year, you have $110. So you are happy about that. Okay? And if you held this $110 and you did not spend it, once again, your parents would give you 10%. You multiply it by 10%. 10% of 110 should be 11. And now, instead of having 110, you have $110 plus 11, which is $121. So let me kind of highlight the years. This is end of year 1, and this is end of year 2. So let me just talk to you about something else also. So back to this question, you had $110, and once again, I told you it was 10%, and we got 121. But the way that you guys saw me do that was you saw me take 110 and multiply it by 10%, take that and add it to 110. But let's say that I wanted to find the answer directly. So the way that we think about that is if you have $110 and that does not change, you have 100% of your money. But because you are gaining an additional 10%, you have earned 110%. So another way to get your answer directly is instead of multiplying 110 by 10% and then adding it to it, you can take 110 and multiply it by 1.10, and this gives you the answer directly of 121. So this idea of if something increases by 20%, that's 120%. If something decreases 20%, that's 80%. So instead of actually finding the percent, like 20%, and taking that off a number, you can just take 80% of the actual number and get your answer right away. So the reason why I bring that up is because all of you have seen this formula, y equals a parentheses 1 plus r to the power of t. So to explain this, in this scenario, a is the initial amount that you invested. 1 represents, don't forget guys, 100% equals 1, because percent means over 100. So if you do 100 divided by 100, it gives you 1. Plus your rate is 0.1. And then t is your time. So if we wanted to do it 1 year, we would do this 1 time. But since we're going to do it 2 times, instead of writing it like this, like if I did this math right here, this would give me $110. Oops. And then if I drop this would give me $121. So that's the crazy thing about this. A nice thing about introducing this 100% is the fact that it allows us to create this formula that directly gives us the answer to our problems. But once again, y'all, I am not going to keep repeating 1 plus 0.10. So instead of doing that, I would write 1 plus 0.1 to the power of 2, knowing that I'm doing this twice because I want to find out how much money I have in 2 years. So by doing this directly, you get 121. So to begin with, this is what we call exponential growth. So far I've talked nothing about compound interest. So just pause the video and make sure that you understand everything that I've said so far. So now we're going to move on and we're going to keep the same scenario rolling. So now, once again, like I said, you have $100. Your parents are paying you 10% interest. And now your uncle comes and your uncle wants to teach you a different lesson. Your uncle wants to teach you about compound interest. So this is what he says to you. He says to you, would you rather take 10% of 100 every year, or let's take this 10% and divide it by 4. So instead of just paying 10% at the end of the year, I'm going to take this percent and divide this by 4 and multiply all the amounts that you get quarterly instead of yearly. So in a year, you're going to do this math 4 times. So if I take 10% and I divide it by 4, this is going to give me 2.5% quarterly. So in a year now, I'm going to do $100 times 1 plus 0.025. And if I did this once, this would tell me my total that I get. If I'm doing this quarterly, let's think of our months. We have 12 months. So that's every 3 months. So every 3 months, we're going to do this process. So this is 3 months so far. So at the end of 3 months, we're going to take $100 and we're going to multiply it by this rate. And we are going to get $102.50. All right. Once again, we've already established earlier, at the end of the year, if we did it once, we got $110. So just keep that in mind in this first scenario. We got 110. So we did it quarterly. We did it 3 months. Then 6 months comes, and we would write the same formula, but this time we would write it 2 because we're doing it twice. And then if you did it 9 months, you would do it 3 times. And then at the end of the year, which is 12 months, we would do it 4 times. And what I want to focus on is I want to focus on 12 months, how much that is. So if I raise that to the 4th, I'm going to get $110.38. So by doing this process quarterly, so taking the interest rate 10%, dividing it by 4, and then taking and then waiting every 3 months and taking 2.5%, I end up with a little bit more than I did with my first scenario of doing it once in a year. So that is the power of compound interest. Because what compound interest tells us is after 3 months, you have $102.50. Then you're taking 2.5% of that. So you're not only getting interest on the initial $100 you invested, you are getting interest on that interest that you earned by doing it several times. So that's the power of compound interest, is that it grows really quickly. And I know a lot of you are just like, what, $110.38? That's not that much. I want to point out two things. Two things is this is only 1 year, okay? If we know anything about exponential growth, it takes time to build. Second of all, the interest rate is pretty low on this problem. If we turned up a little bit and we also turned up on the initial amount, we would see that it's more. But also, y'all, I'm doing all this work, which just looks tedious, right? It's just still too much work. And so I'm going to show you a formula that kind of puts everything together that we are describing here. So the formula for compound interest is P1 plus R over N to the power of NT. So let me explain this. So we're going to use the same scenario. $100, 10% interest rate, compounded quarterly, and then 1 year. So watch this. So you put 100 because that's how much money we have. We know that this 1 stands for 100% plus our rate is 0.10, and this new variable that we are introduced to is n, tells us how many times we are going to take our interest and divide it. So we're going to take our 10% and divide it into 4 pieces because we are going to do it 4 times. That's what compound quarterly means. And I'm going to do it 4 times. So I take my rate, divide it by 4, and I'm going to raise it to the power of 4. It's because I'm taking this new rate. Remember this? This part was the 0.025. So that's what I got by dividing by 4. And then I'm going to do it 4 times. But instead of writing each parentheses 4 times and doing the long work, I'm doing it in a concise manner. And then the time is going to be 1 year. So I put a 1. And then if you solve this in the calculator, you get $110.38. So the nice thing about this formula is you have so much more power. You can compound monthly. You can increase the years. You can say in 20 years, how much will I have? So let's have some fun. And let's say that we wanted to compound our money monthly. So all we do is we make this 12, 12, and 1. And let's see what our new total is. Once again, I do not expect anything crazy, but I do expect something that is a little bit more. And typing this in, and I get $110.47. Once again, it is more, a little bit more, but it is more. And I promise you, as we turn up this time, right? So let's say that you started this when you were 6 years old, and now you're 56. So let's change this time to t. So let's see what we get if we do the same thing, but didn't spend the money until we were 56 years old. We all wanted to go on a vacation. You would have $14,536.99. So that just gives you an idea of how quickly your money can grow and that the great power of compound interest. So I hope this video helps. This just kind of gives you like a background between, for compound interest.